Okay, so this little problem is, let's say, is extremely nasty. Because the calculation is trivial. You just have to take the correct two numbers up above that are kind of hidden and like multiply them together, and you've got the answer. But that's easier said than done. So I want to look, just for the sake of argument, let's look at a composite function. This is what this is, f of g of x. This would be kind of like saying sine of x cubed, right? How do you take the derivative of this? You guys actually know how to take the derivative of this. You go cosine x cubed, and then you times 3x squared. Well, what is that? Well, that's the derivative of the outside function, and then times the derivative of the inside function, but it's not quite that simple, is it? Because the outside function's derivative is being calculated at where this is. That's the inside function. And then inside here goes g of x, you see. So because g of x still has to be calculated, and then the derivative function has to be calculated. Whereas this guy, the x actually goes in here, okay? And so that's what makes this problem nasty, because you got to figure out how all this stuff actually is nested. So h prime at -1 is actually f prime of g at -1 times g prime at -1. Okay, so f prime, well, what is g of -1? Well, it says g of -1 is 2, and g prime of -1. Okay, then f prime of 2 is 4, and g prime of -1 is 3, so the answer is 12. Okay, so I would not expect you to really figure that out without trying a different function and trying to reverse engineer what the rule must be, because we didn't actually talk about it in the abstract. But that's what makes questions so much fun. And I wouldn't give it to you on an exam unless it was something very similar had occurred on a practice exam. Cough, cough. Okay, so I do want to warn you that another very, very similar type of question could occur if you had h of x equals f of x times g of x. Then I do expect that you would be able to figure that out, because h prime of x would be f of x, g prime of x, plus f prime of x, g of x. Okay, and you guys know how to handle that. Okay, so I'm just going to wipe that out, but that's just a remote possibility, you see. Okay, so then this other kind of question down here just feels very much the same. So again, it's probably wise for you to just take a sample function and just see what you think about it. Okay, so if we had cosine of x cubed, how will we find the derivative? Okay, h prime of x would be 3 cosine of x squared negative sine of x, right? So what does that actually mean? So if cosine of x is just an arbitrary function now, this is going to be f of x inside here squared, and then this is minus the derivative. I'm sorry, not minus. The minus is part of the derivative. There we go. F prime of x. There we go. So that's what the function, that's what the generic structure is, just h of x. Okay, so h prime of x is 3 function squared times the derivative of the function. And we want to find the equation of the tangent line of h at x equals 0. So h prime of 0 is going to need to be calculated. So let's just go ahead and do that, because that's probably the most difficult part of the question. And let's see, 3 times f of 0 squared, and then you put f prime of 0. Okay, looks like we're finally getting somewhere. If we square a half, we get a quarter, so we get 3/4 times 8/3, and then this just gives us 2. Okay, so how do we find a tangent line? We need a slope. So this is the slope of our tangent line. Okay, and then we want to find a point. So we need a point on the line is, well, at x equals 0, what is the y value? What is h? We want to know h of 0. What is h of 0? It is the cube of f of 0. And what is f of 0? It is -1/2. And so we get -1/8. Okay, so if that's all right, the nasty stuff is over, and we just have to assemble everything. So we have y equals mx plus b. We know what m is. We know what x is. We know what y is. So therefore we know that b has to be -1/8. So we have y equals mx plus b. There you go. Okay, so if I were a student, I would recommend skipping that one. But, you know, it's kind of fun too. And now that I've shown you, you'd have to look and say, well, how much time do I have? Do it, and then decide if you feel more comfortable with that or some other one. But it's definitely a cute problem.